Hello and welcome in this video. For this exercise, we would like to find out the eigenvalues and eigenvectors of this matrix. So if you want to give a try, please pause the video. Otherwise, let's see the solution. If we want to find out first the eigenvalues of this matrix, we would like to start by finding out the characteristic polynomial. To do that, we need to calculate the determinant of a minus lambda I. So you rewrite, numbers of the matrix, and then you add negative lambda on the diagonal. Then if you calculate the determinant, this is 2 minus lambda times minus 4 minus lambda minus negative 1 times 5. So we end up with minus 5, this is plus 5, and this is equals 0. So if you expand, you end up with lambda squared plus 2 lambda minus 3 equals 0. So this is a quadratic equation. We would like to find out the roots, so we need to calculate what we call the discriminant, b squared minus 4ac, and the value of the discriminant is 16, and we know that square root of 16, this is 4. So we can now calculate these two roots, negative 2 plus or minus 4 divided by 2, and we've got two roots, negative 3 and 1. So the characteristic polynomial can be written as lambda minus 1 times lambda plus 3. So these two roots are these eigenvalues. So now let's calculate the eigenvectors. So first we need to know this formula. A v equals lambda v. A, this is this matrix. V, this is the eigenvector. And lambda, this is the eigenvalue. Keep in mind that an eigenvector is always linked with an eigenvalue. So you start by selecting one eigenvalue. We've got just a choice between 1 and negative 3. So we decide to start with 1. And then you apply this formula and you end up with a system 2x plus 5y equals x and negative x minus 4y equals y. On the left side, you've got the same numbers as you can find in this matrix. And on the right, you've got x and y, and in front of x and y, you've got this number, this eigenvalue. This is 1. So now we would like to put on the same side of the equation all the terms in x and y. So we end up with x plus 5y equals 0 and negative x minus 5y equals 0. So this is pretty much the same equation. So next step, this is to express a variable function of another one. So x equals negative 5y. So now the eigenvector xy can be written as negative 5y and y. So the eigenvector related to 1, this is negative 5 and 1. So now let's calculate the second eigenvector. So let's say that now the eigenvalue is negative 3. We apply the same formula, AV equals lambda V, and we end up with this system on the left. Okay, this is the same numbers as the matrix, and on the right you've got negative 3 and x and y. So we do exactly the same. We are going to put terms in x and y on the same side of the equation, and we end up with 5x plus 5y equals 0 and negative x minus y equals 0. Exactly the same equation pretty much. So now we are going to express one variable function of another one. This is y equals negative x. So now the eigenvector x and y can be written as x and negative x. So the eigenvector linked to negative 3, this is 1 and negative 1. So let's recap the situation. Okay, we've got this matrix, two eigenvalues 1 and negative 3, and two eigenvectors negative 5, 1 and 1 and negative 1. And remember, every time you've got an eigenvector, this eigenvector is related to an eigenvalue. Thanks for watching this video, and I hope to see you in the next one.